everybody. This is investigation 9 on page 616, graphing functions. We have already learned about how to graph x and y coordinates. Hopefully you are getting that pretty good. This is taking it a step further, incorporating that into making graphs. So we're going to see how algebraic equations such as this can actually be converted into x and y coordinates and graphed on a graph and determine measurements and lines based on the information we input. So we're going to go through all the steps of that. I'm going to go through the different algebraic formulas that they give, or the expressions that they give, and then you hopefully can answer all the questions and go through the whole investigation. Okay, on page 616, it tells us that functions can be displayed as graphs on a coordinate plane. To graph a function, we use each x and y pair of numbers as coordinates of a point on the plane. So they give you this equation here, y equals x plus 1. That means whatever you put in for x, y is going to equal 1 more. So if you put in 0 for x, 0 plus 1 would be 1. Y becomes 1. So if you input 0, your output is 1, kind of like the functions that we've been working on before. That means your coordinates on the graph over here are going to be x. You always do x then y. X is 0, y is 1. You put those in parentheses. That's how we always distinguish that those are plots on a point. Okay, if you would put 1 in for x, your result would be 2. So there we go there. So 1 and 2. If we put 2 in for x, the output would be 3. So 2 and 3. And if you put in 3, the output would be 4. Okay, so then we just need to plot these points. And if you have graph paper, which you should all have if you picked up your supplies at school, you should use that graph paper. It will very much help you. You don't have to draw every single line. All you need to do is draw an up and down line and an across line to determine where your center is going to be, and then just count the boxes from there. Let the paper do the spacing and everything for you. Okay, so let's plot these points. 0 and 1, these are all positives, so that gives us an indication that we're going to be in this first quadrant, because this is positive this way, and this is positive this way, and this is negative, and this is negative. Okay, 0 and 1 means we always do the x first, so 0, we didn't go anywhere on the scale here, we're still at 0, but the second number, the 1, is where we go on the y axis. So nowhere this way, but up 1. So I'm going to put a little dot right here. That is 0 and 1. So 1 and 2 would be to the right 1, up 2. Okay. Then the third one, 2 and 3. Go over 2, go up 3. And then 3 and 4, over 3 and up 4. And again, if you have your graph paper, yours will probably come out a lot neater than mine, because I'm just doing this freehand. So when you work these problems, you will be asked to plot the points and then draw a line to indicate the line that goes through. So basically all you do is you connect the dots and then you extend the line farther both directions. So if I connect the dots, I'm simply going to go like this. You might need to use a ruler or a straight edge to do that, but don't just stop there, because what this function means is anything you put in for x plus 1 is going to be 1 more. So that means you could put in higher numbers. You could put in 10 and your output would be 11. So your coordinates would be 10 and 11. Now I don't have room to do all of that on this. So to indicate that, I'm just going to extend my line farther and put an arrow, which means it goes on that direction forever. That means if you would put in a negative number, say if you put in -2, then your output would be -1, and that would be -2 and -1 down this way. So the plots could go different. So you can also make your line go this way, on and on forever. So when you graph these, you need to, and you draw your line, you need to extend it farther than what the dots indicate, and draw arrows, meaning it goes on in both directions. So that should get you started on that. I'm going to show you the next algebraic expression and the plots on 617. All right, on page 517, you will, under the number 2, you will see the equation y equals 1/2 x minus 1. What that means, whatever x is, you're going to multiply it by 1/2 and then take 1 away to get your y. So whatever you input for x, you work it out, and your output would be the y. So let's look at the first one. They've given you these answers already, so let's just go through them. If you put 0 in for x, anything times 0 is going to be 0, so 0 minus 1 is going to be -1. So we've got -1. So this becomes our first set of coordinates, 0 and -1, x and y. And on your graph, you're going to have x, you're going to have y, positive, positive, negative, negative. Let's look at 2. If you put 2 in for x, that would say, okay, well, what's 2 times 1/2? Well, you know that 2 has to be, you have to do it like this, 1/2 times 2 over 1. You have to make it, be able to multiply in a fraction. Well, that cancels, this cancels out. So you know that's going to be 1. So this becomes 1. 1 minus 1 means this is going to be 0. And they have 0 right there. Okay, so that becomes your second points that you're going to plot. If you put 4 in there, that would be 1/2 times 4 over 1, which if you could cancel that out, you would get 2 over 1, which would just be 2. 2 minus 1 would then get you 1. And there's your points there. So they've already given you the answers for these, so you don't have to stress about working these problems out. So these pairs, x and y pairs, become your coordinates. So the first pair is 0 and -1. Let's plot that. So 0 means it's not going anywhere this way, but it is going to go down 1. So there's your first one. 2 and 0, that means we're going to go right 2 and down 0, which means we're not moving. We're staying right on that line. There's your second. Okay, 4 and 1 means you go right 4 spaces and you go up 1 here. So there's your 3 points. If you have at least 3 points, you should be able to, if you do it correctly, you should be able to see where the line is going. And then if you draw your line, I just start here, connect the dots, keep going on for ways, draw my arrow, and then keep going down and draw my arrow. And this line is the graph version of this algebraic equation. So that's how that works. Let's look at the bottom of 617 for the next equation. All right, at the bottom of 617, they show the equation P equals 4s. That means P equals 4 times s. Okay, and then they show you the box that has the points in. If they inputted these numbers for s, these are the numbers they would output. Meaning if you put in 1 for s, you would get 4 times 1, that's 4. P is 4. If you put 2 in for s, then 4 times 2 would be 8. So they have 8 here. If you put 3 in for s, 4 times 3 would be 12. And you have 12 there. Okay, we're going to graph these. Now this gets a little bit confusing because you think, wait a minute, now we have s and p. What happened to x and y? Well, the number you input, meaning you first stick in, that represents the x. I'm going to put a little x over that. And the output number, your answer, is going to be y. So you treat these the exact same way as x and y coordinates, but they're just labeled differently. They give you this information to show you, they have, p would be the perimeter, and in this case, they have the perimeter of the square, and then have the length of side. So that means that the inputs would be, the side, and then the output would be the perimeter. So P is perimeter, and S would be side. Okay, so since these are all positive numbers, I know that when I graph this, I don't really need any negative numbers. So I know that I'm only dealing in the first quadrant, so I'm really only going to have to draw these. So I'm just going to make my little lines like I normally would. I know I need to go a little bit higher because I've got a 12 in here, so let's see if we can fit 12. That'll work. Okay, and I know they're both positive, so I know I'm going to be in this direction. All right, so then we just input these just like x, y coordinates. This would be your x, this would be your y. So first do x and then do y. So we would do over 1 and up 4. And then we would do 2 and 8, 2, and this would be 4, 5, 6, 7, 8, hopefully if I'm doing this right. And then 3 is here, and I know 12 was the last number I did, so that's way up here. So if you do this correctly and you're using graph paper, you should be able to draw a line that is pretty close to this. Now, we're not going to go in the negatives of this because this is actually representing a graph of measurements and things, and we're not going to have negative measurements. You don't measure something negative in inches. They're always positive numbers. So I know that I can start at 0 because if you put a 0 in for s, your answer would be 0. So you'd have 0 and 0. So I'm going to begin here and just connect my dots. Sorry if I go a little crazy with my lines, and I know that will go on forever if I put higher numbers, so I'm going to put an arrow there. I did not put an arrow down here because I know I'm not going to have negative measurements, so nothing goes beyond the 0 point or the origin. Okay, and this would be the line, hopefully yours is straighter, of this equation. Okay, we're going to flip over to 618 and look at one more equation and coordinates. All right, on the bottom of 618, they show us another equation, which is d equals 3h, which means the 3 is times the h. H is your input number, and then d is your output number. So this would be represented by x, this would be represented by y. So if you plug each of these in here, the outcome would be the one next to it. So we don't need to go through that. I know you guys know how to multiply. So to graph these again, I know these are all positive numbers, and this is dealing with distance in miles and time in hours. So we have hours and we have distance. We're not going to have negative hours. We're not going to have a negative distance. So we have to have all positives. So again, we don't need to worry about graphing everything, just the first quadrant. So let's go ahead and put some lines here. Okay, and we're going to go ahead and plot these. Okay, so since this is our input number, that would be the first one. The h's would be where the x's go. So 1 and 3 would be 1 and 3. 2 and 6 would be 2 and 6. And 3 and 9 would be 3 and 9. And again, I know if I put 0 in there, the outcome would be 0. So I know we start here right at the origin. And again, simply draw your line and make an arrow indicating it goes on forever. So that basically, this is a graph that shows your time in hours will indicate your distance. So in other words, as your time increases this way, your distance increases much more rapidly, is basically what that's showing. So I hope we can work through that. If you have any questions, let me know.